There are many things a customer considers when choosing a new car. Elegance, technological advance, lively performance, driving comfort. It's not often that a motorist buys a particular car because he thinks it's safer than another. But the modern motor car industry cannot ignore the safety question. One of the most difficult and expensive problems facing the industry today is the need to design and manufacture increasingly safe cars. Safety is considered by the designer of a new car right from the earliest stages of its development. It is indeed one of the basic elements in his work. When the new car has reached the prototype stage, hundreds of tests are carried out, not only to check its performance under the least favorable conditions, but also to perfect all those individual items on which safety depends. An efficient heating system, for instance, provides comfort for the driver and passengers, and is of vital importance in ensuring safe motoring, even when temperatures are extremely low. Traveling for mile after mile over icy surfaces or across a frozen lake rarely tests a car's road holding. Thousands of miles of pave is one way of making sure that the seats and driving position are comfortable, so the driver won't be overtired by the continuous stresses created by roads of this kind. Road holding on winding roads and on wet surfaces is accurately checked by testing the cars on specially built test circuits. Fiat investigates the reactions of a moving car meeting a strong side wind by ejecting a jet of water from the car at very high pressure. This generates by reaction a sideways thrust equivalent to a crosswind of 50 miles an hour. Meanwhile, in the labs, scientific development of the prototype continues. Every component in the vehicle is subjected to stresses simulating the most severe service conditions. Accelerated testing of this type gets results within a few days, which would take months and months of work to obtain on the road. One of the basic problems in vehicle safety is the resistance of the fuel tank to damage in a collision. A series of rear-end collisions establishes the best position for the fuel tank, and particular attention is paid to the efficiency of the flexible pipe between filler and tank. No leakage of any kind occurs even after severe impact, not even when the tank is full to the brim. Even the choice of a component like a door handle, for instance, is closely linked with the question of safety. A door handle which protrudes too far is a positive danger skimming past an unwary pedestrian. Numerous tests repeated over and over again discover the safest solution which eliminates all danger. Special attention has to be paid to the effects of impact with the windscreen and to ensure the safety of driver and passengers. The front of a car body is fitted in turn with laminated and toughened windscreens against which a dummy is thrown. These tests and experiments pinpoint the different characteristics of the two types of windscreen in impact tests. The problem of residual visibility is also taken into consideration by simulating the sudden breakage of a windscreen while the car is moving. Much research is devoted to safety belts. 3 types are tested in the presence of experts, medical experts among them. In the first test, a lap-type belt is used. The car with a dummy aboard is catapulted forward at a speed of around 30 miles an hour and suddenly halted. Let's have another look at the same test, this time in slow motion. The second type of belt now installed in the car is the diagonal type. This test, seen again in slow motion, means the reactions of the dummy at the moment of impact can be carefully evaluated. last test is designed to measure the effectiveness of the lap diagonal belt. The passenger's body is restrained at the shoulder and waist. So much for the driver. Now let's see how the car behaves. The front and rear sections of the car body should be deformable in an accident, while the center section